Hello and welcome, my dear students, to yet another video on my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session on Lesson 7.5 Multiplying Matrices. Our learning objectives in this session would be to learn how to multiply two matrices and to further use the properties of matrix multiplication for solving different problems. This video is going to be very helpful for all my grade 10 elite math students who are preparing for their term 3 continuous assessment exams, and this lesson I've taken from your math book on page 35. So let's dive into the video. Okay, so first I give you the condition that you need to check when you are trying to multiply two matrices. So if you have two matrices A and B of a particular order, let's see, if matrix A has order m cross n, means it has m rows and r columns. And you have another matrix B which has r rows and t columns. So matrix B has r rows and t columns. So what you need to check first, that the number of columns in matrix A, the first matrix, and the number of rows in the second matrix are equal. They need to be same. This is a first prerequisite condition in which you say that the matrix AB, the multiplication is well defined, and the resulting matrix that you're going to get, AB matrix, after you do the multiplication is going to have the remaining dimensions. So its dimension would be m rows and t columns. So this is the basic condition that you will check for dimensions of matrix products. Let's take an example. Determine whether each matrix product is defined. If so, state the dimensions of the product. So in A part, you have a matrix 3 cross 4, means it has 3 rows and 4 columns. The second matrix B has 4 rows and 2 columns. So just check, is the condition well defined for the product to be possible? So the number of columns and the number of rows, correct, both are equal. Both are equal to 4. So it means the product AB is well defined, and the resulting matrix is going to have the remaining dimensions. So AB matrix is going to have 3 cross 2 order, means 3 rows and 2 columns. So it's well defined. Let's look at the other example, B matrix. Here the first matrix has 5 cross 3 order, means 3 columns, whereas the second matrix have 5 cross 4, means 5 rows. They are not equal. So the number of columns of the first matrix A is not equal to the number of rows of matrix B. This condition is not true. So can the multiplication be defined? Not at all. So AB, the multiplication is not defined. And if it is not defined, there is no need for us to go into the dimension. Matrix product will be undefined. Okay, so if you've understood the concept, let's do some more questions for practice. This I'm going to discuss in the video, and this one would be for you to try. So you have to check whether the matrix multiplication is well defined in each of these cases or not. So here the first matrix A has order 4 cross 6, and the second matrix B has order 6 cross 2. So let's check the number of columns here, the number of rows. Oh, it's same. So because it is same, it is well defined. So AB matrix multiplication exists. It is well defined. And what will be the resulting order when you multiply? It will have the remaining dimension. So 4 cross 2 means 4 rows and 2 columns. So this is all about A part. I'm sure you'll be able to now try B part here. Okay, now I'm going to give you the most important part of the lesson, which is the key concept of multiplying matrices. So there's a particular rule that we are going to follow when we are going to do the matrix multiplication, and it says that the product of two matrices that you're trying to multiply is found by multiplying the columns and the rows. Very important. Let me read it in words. The element in the mth row and the rth column of the matrix AB is the sum of the products of the corresponding elements in row M of matrix A and column R of matrix B. I know this sounds complicated, but I'll try to make it easy for you. So let's look at these symbols. More than the sentences, I feel the symbols and the examples will help you understand the key concept for matrix multiplication better. So first of all, I have here the rule for 2 cross 2 matrix. Let's see how it is working. So the first row, I'm going to write like this: R1, R2, C1, C2. Okay, so the first row of the first matrix A will be multiplied with the corresponding elements of the first column. So row of first matrix and column of second matrix. You multiply corresponding elements and then take their sum. So what is happening? A will be multiplied with corresponding element E. B will be multiplied with corresponding element G, and in between their result will be added. That's for the first part. So this was first row, first column. Okay. And it gave you the first element. Now, for example, I want to write the element which is going to come here. Means it is the second row and the first column. So you will take second row and first column. So C multiplied with E plus D multiplied with G. That's this element. Again, this element is the first row, first column, second column. So you will take, I will change color, first row here and second column here. So A multiplied with F plus B multiplied with H. That gives you this element. And finally, this one is the second row, second column element. So you will take the second row CD with the second column FH. So C multiplied with F, product, plus then addition, D multiplied with H. So that is what is matrix multiplication. Now, as I told you, example would make the understanding easy. So let's take an example. So I'm taking the same kind of a matrix 2 cross 2 and trying to multiply it with another 2 cross 2 so that I know the result is also going to be a 2 cross 2 matrix. Now we are going to define it in such a way that you can see clearly what's going to happen. So I'm making these blank lines to show you what elements we are going to be writing. Let's fill some numbers here. 7, 2, minus 1, 0. I'm randomly taking some example. 3, 2, 4, minus 5. Okay. So these are two matrices. Now, when I'm going to write the elements, see roughly this is the first row, first column. So I take the first row and first columns. 7 multiplied with 3 plus minus 1 multiplied with minus 5. That's the first element. Then I change the color. So first row and second column. So means first row and second column, this entry. So 7 with 4 plus minus 1 with 2. That's the element. Let's move on to another one. This is the second row, first column. So it should be this element, second row, first column. So 2 multiplied with 3 plus 0 multiplied with negative 5. And finally, last one, second row, second column. So 2 with 4 plus 0 with 2. So let's just simplify finally. So this is 7 multiplied with 3, 21 plus 5. Here you have just 6 left. Here you have 8 left. And here it is 28 minus 2. So 26. So final matrix is 26, 26, 6 and 8. I hope that example helped you understand the rule better. Let's solve some more questions on multiplying matrices. Okay, so I'm taking one more example just to make you feel more comfortable with multiplication of 2 cross 2 matrices. So let's find UV. Again, it is going to be a 2 cross 2 matrix. I'm going to do in a similar way 4 blanks so that we start to fill these 4 positions one by one. So first row of the first matrix, first column of the first matrix. So 5 multiplied with 2 plus 9 multiplied with 6. Next we take the first row of the first matrix, the second column. So first row and second column. So this element is going to be filled. I hope you're understanding how I'm doing first row, second column. So that's why I know I have to fill in here. Next is second row, first column. So negative 3 times 2 plus negative 2 times 6. So this one goes with this one. Last but not the least, second row and second column. So negative 3 with negative 1 plus negative 2 with negative 5. So a lot of signs involved here. We need to be careful. We are not making any mistake. So 10 plus 54 minus 6 minus 12 minus 5 minus 45 3. Now negative negative becomes positive, so it becomes plus sign. So we have 64, negative 18, negative 50 and 13. So let's check our answer. Yes, that is perfectly correct. So this is how you do the matrix multiplication. Simplest matrix, 2 cross 2 order. Okay, now we are moving ahead. Now that we've understood and we've become more comfortable with matrix multiplication, to the matrix multiplication properties. So let's use these properties now to solve some question. Herein you are given the commutative property. What is that? Let us recall. If you multiply A matrix with B in that order, A multiplied with B, or you do B multiplied with A, you change the order of matrix multiplication. Is it going to be equal? That's what you need to check. So determine if AB is equal to BA. Is it true? So we are till now not sure. We are just given two matrices. These are square matrices of 2 cross 2 order. So definitely we are going to find them one by one. AB and BA and then compare. Are they equal? Yes or no? So let's write them. And I hope when I'm writing them, you're understanding what is the difference between these two. So here you write A matrix first, then you write B matrix. And for BA, you first write B matrix and then you write the A matrix. So the order is different. However, now that you know the rule for multiplication very well, we are going to directly move to the multiplication steps and then in the end we are going to compare. So let's go ahead and finish this up. So 4 multiplied with negative 3 plus 4. Here 4 multiplied with 6 minus 5. 5 multiplied with negative 3 plus 8. 5 multiplied with 6 minus 10. So what is this? Negative 12 plus 4. So negative 8. Negative 15 plus 8. So negative 7. Here 24 minus 5. So plus 19. 30 minus 10, 20. That's your first matrix. Let's do this now. B times A. So the only difference is in the order of multiplication. So this with this, negative 3 times 4 plus 6 times 5 comes here. Here you get negative 3 times negative 1 plus 6 times negative 2. Negative 4 times 4 plus 5 times 5. And finally 4 plus. Now I'm quickly writing the steps because I hope just like me you've become more comfortable. So this is 6 5s are 30 minus 12. This is 25 minus 60. This is 3 plus with a negative sign, so this one, and minus 6. So what is the final thing? Let's write 8, negative 9, negative 6, and 9. So definitely they are not equal. Both are different matrices. As you can see here, the comparison gives us different answers. So these two matrices are not equal. Commutative property of matrix multiplication does not hold. So the result is AB not equal to BA. Conclusion. Okay, let's solve this question now. Again, this is on matrix multiplication properties. We are going to, in this question, verify the property of distribution. So what you need to check? You need to check S plus T multiplied with R, is it equal to SR plus TR? So this is called right distributive property. And why it is called that? Because from the right you are multiplying this matrix R to the sum of two matrix S plus T. So we have actually three matrix R, S, T given in the question. We need to check whether this is true or not. So we are going to begin with the matrix on the left. So left hand side of this equation is S plus T multiplied with R. So we are going to first add S with T. All of these are square matrix, so there's no problem with the order, whether we are going to multiply or add, both are going to be correct. So let's add S and T matrix first. So it will be corresponding addition, S plus T, and then 6 plus 7. Here negative 2 plus negative 4, 5 plus 8. This is the addition, and to this result you are multiplying this matrix R. So this is what we are going to be doing. Let's simplify it a little bit more. So this is 1, negative 6, 13, 13. And to this we are multiplying 2, 1, negative 1, 3. Order is same, so there is no problem. The order of the result will also be 2 cross 2. So 1 with 2 is 2, and 13 with 1 is 13. Then 1 with negative 1 is negative 1. 13 with 3 is 13, 9. 6 with 2 is negative 12 plus 13. And finally 6 with 6 is 6 plus 9. So let's simplify and get the final answer here. So 15, 1, 38, and 45. This is the result of the right hand side. In a similar way, you can proceed with left hand side, and the only difference here is first you will take the product and then you will add. So S multiplied with R plus T multiplied with R. Now I'm not going to solve the whole thing, but I will just give you a hint here and then you can check your answer. So this is S multiplied with R matrix first. You do the multiplication first, then you do the multiplication of TR. So matrix T with matrix R. And when you are going to be doing that multiplication, you would see that it is also giving you the same matrix. The result is same, 15, 1, 38, and 45. So the left and right hand side will come out to be equal. And because they are equal, this property of distribution, right distributivity of matrix R over the sum S plus T is true. So we have verified this matrix multiplication property. That's how you check. Okay, so let's now do some questions from your math book. These are unsolved questions under the topic of check your understanding given towards the end of this lesson. So first we need to check whether these matrix multiplication is defined or not, and after that we need to find the resulting matrix. So for the first matrix, 2 rows 3 columns, this is 2 cross 3 order, this is 2 cross 2 order. For this one also, this is 2 cross 2 order, 2 rows 2 columns, 2 rows 1 column. So let's check whether the condition is true or not. The number of columns here and the number of rows here should be equal. But that is not true. So we can safely say matrix multiplication is undefined, as the number of columns of first matrix and the number of rows of second matrix are not equal. What about this? The number of columns and the number of rows, they are um, well defined, they are equal. So therefore the resulting matrix will be 2 cross 1. 2 cross 1 means 2 rows 1 column. So we need to fill these two. Let's fill it up. So the first row, first column, so 2 multiplied with 6 plus 8 multiplied with negative 7. Now since the result has only one column, we are just going to write below this. So the second entry we will get from second row, first column. There's no other column, right? So this is a pretty simple one. 3 with 6 plus minus 1 with minus 7. Just multiply it now. So 12 minus 56, and this is 18 plus 7. You can simplify it further. This will give you negative 44, and here you will get 25. So that's your matrix multiplication, and you can check it has 2 rows, 1 column. So it's well defined. Okay, so let's try now some more bigger matrices. We are going to do question 10 here now, and then you girls will try this question yourself. That's your homework. Let's check your understanding. So 1, 2, 2 rows, 3 columns. This is a 2 cross 3 matrix. 1, 2, 3, 3 rows, 3 columns. This is a 3 cross 3 matrix. So well defined because the number of columns and the number of rows here are equal. The resultant after getting the multiplication will have 2 rows and 3 columns. So let's write it accordingly. We are going to write a bigger one because there are going to be 3 columns. I'm writing it pretty big. This is the first column with the first row, first column with the second row, first column, second column with the first row, second column with second row, and third column with first row, third column with second row. Let's try to write the first element, first row, first column. So negative 4 multiplied with 2 plus 3 multiplied with 8 plus 2 multiplied with 5 comes here. Now below this, second row, first column. So we can change the color. This is the second row, first column. So negative 1 times 2 plus negative 5 times 8 plus 4 times 5. Next we have this element. So this is first row, this one, and second column. So negative 4 times 1 plus 3 times 4 plus 2 times 3. Similarly here we have the second row, and the second column. So negative 1 times 1 plus minus 5 times 4 plus 4 times 3. Now similarly for this one, first row, third column now. So this is the column we are considering with the first row. So negative 4 times 6 plus 3 times negative 1 plus 2 times negative 2, and similarly last but not the least, negative 1 times 6 plus negative 5 times negative 1 plus 4 times negative 2. So as you see, a lot of signs here. We need to be very careful with the sign convention not to make any sort of mistake while we're doing the calculations. This is negative 8 plus 24 plus 10, negative 2, negative 40 plus 20, negative 4 plus 12 plus 6, negative 1 minus 20 plus 12, negative 24, negative 21, negative 4, finally negative 6 plus 5 minus 8. Now I'm doing it without a calculator, so it's taking me little more steps. You can just plug in everything in your calculator and get your answer straightforward. So the first element, 34 minus 8. Next one, negative 2, negative 20, negative 22. This is 18 minus 4, 14. This is uh, negative 9. This one is negative 9, 4, negative 49. This is negative 9 again. So the result finally, the last answer, which is having as we want 2 rows and 3 columns. So this is having the following elements: negative 26, sorry, plus 26, negative 22, 14, negative 9, negative 49, and negative 9. So we have done our final answer. This is how you will get the multiplication matrix. Do try question 11 and write in the comment section what answer you got. Any questions and query, you can put it in the comment section. I'll be there to help and guide you. That brings us to the end of matrix multiplication. I hope you found the video useful, and if you do, don't forget to give it a thumbs up and put in your comments and suggestions. Make sure you hit that bell icon to receive notification of my upcoming videos. More videos for matrix multiplication and matrix operations coming up. Stay glued to the channel and see you in my next video.